Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are going to help the students who are preparing for CSIR-NET, GATE, NT exam, PhD exam, SET exam, Jest, IIT-Jam, Tifr and other exams related to physics. So my courses are absolutely free of charges. So this is the lecture number third for quantum mechanics CSIR-NET PYQs. Okay. So before starting the class, I thank you everyone who subscribed my channel, and also I would request the people who haven't subscribed my channel yet, please subscribe my channel. Okay, so this is the lecture number third for quantum mechanics PYQs. Okay, so I'll start now. I'll start with question number first. Okay, so question first is, let zero state and state 1 and state 1 denote the normalized normalized eigenstates 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 corresponding to corresponding to the ground state and the ground state and first excited state first excited states of a one dimensional of a one dimensional one dimensional harmonic oscillator harmonic harmonic oscillator the uncertainty the uncertainty the uncertainty delta p in the state in the state in the state 1 upon root 2 cat 0 plus cat 1 inside the state, okay, is Options are option number A, delta P equal to root h cut m omega upon 2. Option B is delta P equal to root m omega h cut m omega h cut upon 2 whole root, and option C is delta P equal to root m omega h cut, and option D is delta P equal to root 2 h cut m omega. Okay, so these are the options which are given. Okay, so the question is, let 0 and 1 denote the normalized eigenstates corresponding to the ground state and first excited state of one-dimensional harmonic oscillator. The uncertainty in delta P in this state 1 upon root 2 cat 0 plus cat 1 is. Okay, so we have to find out delta P, uncertainty in delta P. Okay, and we know there's a formula, right? You need to note down in this state n, in this state n, the values of, in this state n, this expectation value of momentum is 0. Okay, and expectation value of momentum square is n plus half m omega h cut. Okay, similarly in the same state x, expectation value of x operator is 0, and position operator, and x square is n plus half h cut upon m omega. Okay, this you need to know and note down. Okay, this we know. Okay, now we have to find out the uncertainty in delta P, and we know uncertainty, right? Delta P is root expectation value of momentum square into expectation values whole square of average value of P whole square, right? That is momentum, right? This we know. But here we need to find out we need to find out delta P uncertainty in this state, this 1 upon root 2 0 plus 1. Okay, this you need to note down, guys. Okay, this is in this state n. Okay, so we have been given psi equal to that is 1 upon root 2 0 plus 1. This is what is given. In this state we need to find out this. Okay, and we know the P. We know P. Value of P is iota root m omega h cut by 2 a dagger minus a. Okay, this we know. Okay, and similarly there also we know, I'm writing for position as well, right? That is, value of x is root h cut upon 2m omega a dagger plus a. Okay, these are the values. I'm writing for position operator as well with momentum operator, because you may get a question like the uncertainty in delta x as well, right? That's why these are the values of p and x. This is the momentum operator. These are the values of p and x in one dimensional harmonic oscillator. Okay, so now we'll find this one, expectation value of p in this state psi. Okay, in this state psi, this one, expectation value of p is going to be, that is psi p psi. Okay, this is a normalized function actually. Okay, so this is the p, and so we'll put the value, that is value of p is iota root m omega h cut upon 2 psi dot a dagger minus a psi. Okay, this is what value, and this value is 0 actually. Okay, this value is 0 because if you put the value like iota m omega h cut upon 2 root, this is psi, the value of psi we know, this is 1 upon 2. This is the value of p, guys, we have to capture. Okay, okay, so we'll put the value here, because value of p is, I've already written this is the value of p, right? We have written this, and psi is this given, this one. Okay, so this is going to be 1 upon 2, and we know how to operate a dagger, right? So we'll put the value, this is 0 plus 1 into a dagger minus a, and this is 1 upon root 2, 1 upon root 2, this is 1 upon 2. Okay, so this is going to be 0 plus 1 Okay, this is the value, right? And we know here that if you operate a dagger with n, okay, so this value is going to give n plus 1 root n plus 1, and this one state will get increased, so 1 n plus 1 we know. And similarly, if you operate a with n, it is going to be root n, one state will get decreased, so it's n minus 1. This we know, right? So similarly, if similarly here, if you operate a dagger with 0, this value is going to give 1, because it's going to be 0 plus 1, and this is 0 plus 1, right, state. So it is going to be, the root 1 is 1, so 1, right? Similarly, with the help of these formulas, a a0 is going to be 0. Similarly, we can find out a dagger 1, a dagger 1, right? So this is going to be root 2 into state 2, or a with 1, it is going to be 1, root 1 is 1, and this is going to be 0 state. Okay, so we'll operate a with this and a dagger with this, and after calculation this value is going to be 0. So value of p, the expectation value of momentum is 0, but we have to find out expectation value. So with a dagger, and a, it is going to be 0. Okay, so this is the value. So now what we are going to do is, we'll find out the expectation value of momentum square. Okay, so for that, this is going to be, because we have value of p is this, and we'll and we have to find a whole square of this, right? So this is going to be, I square is going to be minus 1. I'll write first, that would be easy for you. So I square is minus 1, and then m root m omega h cut by 2, it is going to be, the root will get removed because there is a square, right? So 1 minus 1 into 1 into h cut omega m by 2 into a dagger minus a whole square. This is going to be like this, right? So now we'll open it, so it is going to be minus m omega h cut upon 2, and this is, will open this whole, a dagger square plus a square minus a dagger a minus a dagger. Okay, and since we know there's a number operator, a dagger a is n. Okay, this is called number operator, and a dagger is n plus 1. We'll put the value here, so it is going to be minus m omega h cut by 2 a dagger square plus a square minus, this is going to be n into n minus minus plus 1. Okay, so this value is going to be minus m omega h cut by 2 m omega h cut by 2, and this is a dagger square plus a square minus 2n plus 1. We can write this like this. Okay, so this is the one we can write. Okay, Now we'll find the value of, this is just a value of p square. Okay, now we'll find expectation value of p square. Expectation value of p square is going to be minus m omega h cut by 2 into psi. Value of psi we know, it is a dagger square plus a square minus 2n plus 1. This is the value of p square, right? Into psi. Okay, so we'll put the value. So so if you operate, because we know we have operated a here, this p with this, right? This one we have operated, right? This psi with this with aa. So this has given the value 0, right? So similarly, a square plus a is also going to be also going to give value 0. So it is going to be minus m omega h cut by 2. This will be psi into 2 and minus minus will get plus 2n plus 1, 2n plus 1 psi. Okay, this one. So after operating this is going to be m omega h cut by 2, and we know value of n is a dagger a, right? So after solving this is going to give 2 into 1 by 2 plus 1. Okay, so this value is going to be m omega h cut. Okay, so value of p square, that expectation value of p square is this, right? So now delta px, that is uncertainty in delta px, is going to be expectation value of p square minus expectation minus p average whole square, right? This value is 0, so it is going to be m omega h cut minus 0, and that is going to be root m omega h cut. Okay, so this is the answer, guys. So which option is matching? We'll check it. Very important question, and many things get cleared, right? So option number C is the correct one. Okay, C, that is root m omega h cut. Root m omega h cut. Okay, so this is the root m omega h cut is the correct answer. Answer C. Okay. Now we are going to solve question number 2. It's a very important question, guys. I have solved, and many things I get cleared for you. Okay. Okay. So next one is, let me just check, is connection working fine? Okay, it's fine. Question number 2 is, the wave function of a particle wave function of a particle at time t equal to 0, at time t equal to 0 is given by psi 0 psi 0 is 1 upon root 2 u1 plus u2, where u1 and u2 are normalized eigenstate, are the normalized normalized eigenstates with eigenvalues e1 and e2 respectively e2 greater equal to e1 the shortest time after which the shortest time after which psi t will become orthogonal to psi 0 is, okay, options are given. Option A, minus h cut pi upon 2 e2 minus e1, Option B is h cut pi upon e2 minus e1. Option C is root 2 h cut pi upon e2 minus e1, and option D is 2 h cut pi upon e2 minus e1. Okay, so this is the question. The wave function Okay, just wait guys, system is getting hanged. Okay, the wave function of a particle at time t equal to 0 is given by psi 0 is 1 by root 2 u1 plus u2, where u1 and u2 are normalized eigenstates, okay, with eigenvalues e1 and e2 respectively, e2 greater or equal to e1, which is given the shortest time after which the psi t, the wave function psi t will become orthogonal to psi 0 is. So we need to find out time when psi t will become orthogonal to psi 1, okay, that's what we need to find out. Okay, first uh, uh, we'll write whatever is given in the question, that is psi t is given, this is 1 upon root 2, 1 upon root 2 u1 plus u2, okay, and psi 0. Now we know how to find psi t, okay. Wave function psi t, let the shortest time is t, okay. So this is going to be 1 upon root 2 u1 e to the power minus iota et upon h cut, okay. For getting t, right, psi t, so we will multiply this by e to the power uh, minus iota e1t, okay, plus second is going to be u2 e to the power minus iota e2t upon h cut, okay. So this is the psi t. So for ortho, and you know u1 and u2 are you are normalized wave functions, okay, normalized eigenstates, which is given. So this is going to be, and we know the orthogonality condition, right? uh, Here question is the shortest time after which psi t will become orthogonal to psi 0, right? So orthogonal condition we know, right? That after time t they become orthogonal. So orthogonal condition is psi 0 and psi t orthogonal means psi 0 psi t, the expectation value of this is going to be 0, right? This is the orthogonality condition, right? So this value is going to be 0 for orthogonality. For this value is going to, okay, so their product is 0. So we'll write here 1 upon root 2 u1 plus u2. Okay, wait, this is the cat, right? So we need to find out this one bra, and there is no iota, right, imaginary part, so this will be the same. So this is going to be 1 upon root 2 u1 plus u2, okay. This will get operated with this one, 1 upon root 2 u1 e to the power minus iota e1t upon h cut, okay, plus u2 e to the power minus e2t upon h cut, okay. This is iota also here, iota, okay, this one. So since u1 and u2 are normalized eigenstate. It means u1 u2, the product of u1 with u2, that is u1 with u1 u1 with u1 is going to be 0, and sorry, this is 1, this is 1. Similarly, u0 with u0 is going to be 0, sorry, 1, 1, and u1 with u0 is going to be 0, and u0 with u1 is going to be 0. This we know because u1 and u2 are ortho normalized. Okay, so now this is going to be 0, and now we'll operate with this. So this value is going to be 1 upon 2 1 upon 2 1 upon 2 e to the power minus iota e1t upon h cut plus e to the power minus iota e2t upon h cut equal to 0. Okay, so now we'll take this in right hand side, so it is going to be 1 upon 2 e to the power minus iota e1t upon h cut equal to minus 1 upon 2 e 1 upon 2 e to the power minus iota e2t upon h cut. So this will go here in numerator, and this will one by one this get cancelled. So it is going to be e to the power minus iota e2 minus e1 t upon h cut is going to be equal to minus 1. Minus 1 we know the value, right? So it is going to be e to the power minus iota and this value we know, right? This value is e to the power 5, right? So this is going to be implies minus iota e2 minus e1 upon h cut is going to be 5, right? Minus minus will get cancelled actually. Yeah. Wait. This is minus 1, right? So this minus 1 value is 5. So yes, minus 5, it will be minus 5, minus 5. Okay, so this is actually going to be, no, this sign is not minus. This is the e2 minus e1, right, guys? Okay, so this will go, this sign will get plus. Okay, e2 minus e1 equal to pi. So it is going to be pi, right? So implies the expectation, the value of t we can find out from here, right? So value of t is going to be h cut pi upon e h cut pi upon E2 minus E1. Okay, this is the answer, guys. Okay, so which option is matching? Let's see. So option B is the correct one, h cut phi upon E2 minus E1, right? This is h cut phi upon E2 minus E1. So option B is the correct option. I hope guys you understood the question, solution and question. Okay, so now question number third we are going to solve. Okay, so question is a constant perturbation a constant perturbation as shown in the figure, as shown in the figure, as shown in the figure below, acts on a particle, acts on a particle, acts on a particle of mass m, of mass m, particle of mass m, confined in an infinite potential, an infinite potential, an infinite potential well between 0 to L, 0 to L, okay, and the figure is given. I'm going to make a figure. This one, this is V0 by V0 by 2, this is V0, okay, this is 0, this is L, and this is L by 2, okay. This is the figure which is given. This value is V and this value is V, right? Okay, so this is given, and then the first order correction to the ground state energy, the first order correction to the ground state energy, first order correction to the ground state energy of a particle, is, options are V0 by 2, option B is 3 V0 by 4, option C is V0 by 4, and option D is 3 V0 by 2, okay. Okay, so question is a constant perturbation as shown in the figure below acts on a particle of mass m confined in an infinite potential well. between 0 to L. Okay, between 0 to L, and this is the figure given, right? This height is V0 by 2, this is V0 and L and this, right? So now you need to find out the first order correction to the ground state energy of particle. First order correction, okay? You need to find out first order correction. So there's a typical method we use, right? So here I'm going to use trick, okay? So and you can solve it with actual method as well. I'll just give hint, right? So very simple. What you need to do is ground state energy in first order E, the correction to the ground state energy in first order is, that is psi h psi, right? And this is going to be integration, because the value is 0 to L, right? L by 2. It is going to be 0 to L by 2, and we know the value of psi, right, for infinite potential valve, that is root 2 upon L sine pi x upon L, right, for 1D infinite potential power. So we'll just write this. So it is going to be to 0 to L by 2. This is 2 by L sine square pi x upon L plus this is dx plus L by 2 to L 2 upon L 2 upon L sine square pi x upon L, and this is V0 by 2, and this is V0, just V0, okay, V0 dx. If you solve it, it will give the value, right? This is the normal method, the actual method, but here we are going to use trick. So you just need to integrate it, right? You know how to convert sine square, right? So we know cos 2x equal to 1 minus 2 sine square x, right? So with this formula you can replace sine square and integrate it, and you will get the value. This is the actual method, but here, because in examination time, we need short method, so that we can save time, and we can solve more question, and there are less probability of getting answer wrong if you know the short trick, right? So here we know. So what we are going to do is we'll get the volume of this part plus volume of this part, total volume, and then we'll remove the L, and in this way we'll solve it. Okay, so trick. Okay, just let me check. So trick, I'm going to solve it by red pen. Okay, trick. So volume of this part, it is, this length is L by 2, and this length is this is V naught by 2, right? V naught by 2. So this is going to be, the volume is going to be V naught by 2 into L by 2 plus this volume, total volume. Okay, so this is L by 2 into V naught, L by L by 2 into V naught. We'll solve it. So this is going to be V naught L by 4 plus V naught L by 2. So this is going to be 3 V naught L upon 4, right? So therefore correction to the ground state energy in first order is going to be, we'll remove the L, so this is going to be E V naught 3 V naught upon 4. This is the answer. So very simple, right? So we have got answer quickly. Okay, so this is the answer, guys. We'll check which option is matching here. So option number B is the correct one. Okay, so this is the question number 3rd. Now we are going to solve question number 4. There's some issue, just let me check. I'm not able to change the ink of pen. Okay, just let me check again. Okay, it's okay. So I'm going to use red pen now. So red ink. Okay, so it is question number 4. A particle of mass m, a particle of mass m is in a cubic box, is in a cubic box of size A, of size A. The potential inside the box, the potential inside the box, the potential inside the box, that is, which is axis between A, 0 to A. Okay, similarly y is between 0 to A, and z is between 0 to A. Okay, is 0. The potential inside the box is 0, is 0 if this condition is there, and infinite outside, and infinite outside, if the particle is in eigenstate, if the particle is in an eigenstate of energy, eigenstate of energy E equal to 14 pi square h cut square upon 2 ma square its wave function is, its wave function is. Okay, options are option number A, that is psi equal to a upon 2 upon a 2 upon a to the power 3 by 2 sine 3 pi x upon a 3 pi x 5 pi y 5 pi y upon a sine 6 pi z upon a 6 pi z upon a and option B is psi equal to 2 upon a sine 7 pi x upon a sine 4 pi y upon a sine 4 pi y upon a sine 3 pi z upon a sine 3 pi z upon a. Option C is psi equal to 2 upon a to the power 3 by 2 sine 4 pi x upon a sine 4 pi x upon a sine 8 pi y upon a sine 8 pi y upon a sine 2 pi z upon a sine 2 pi z upon a. Option B is 2 by a. Okay. Psi equal to 2 upon a to the power 3 by 2 sine pi x upon a sine pi x upon a sine 2 pi y upon a sine 2 pi y upon a and sine 3 pi z upon a sine 3 pi z upon a. Okay, so this is x. So this is the question. Okay, a particle of okay, so a particle of mass m is in a cubic box of size a. So the particle is in cubic box. Okay, the potential inside the box is 0. Okay, the condition is x should be between 0 to a, y should be between 0 to a, and z should be between 0 to a. Okay, and outside the box the potential is infinite. If the particle is in eigenstate of energy this, okay, so particle is in eigenstate of energy this, then it's a wave function we need to find, and options are given. Okay, so I'll solve now. Okay, okay, so now I'm going to solve it. So we know that we know if particle is in 3 dimension, then an eigen value, that is energy, is nx e nx comma ny comma nz equal to that is nx square plus ny square plus nz square pi square h cut square upon 2ma square, right? That's what we know, the eigen value, right? Or energy eigen value E, that is E nx ny, because it is in 3 dimensions. So this is nx square plus ny square plus nz square into pi square h cut square upon 2ma square, right? And since we have been given En is also given 14 pi square h cut square upon 2 ma square, that is given in the question, right? This one, okay. So so implies this is going to be equal to 14 pi square h cut square upon 2 ma square. 14 pi square h cut square upon 2 ma square, right? And so these values are equal to this. This implies the value of nx, because total should be like this, right? So value of nx should be 1 and value of ny should be 2 and value of nz should be 3. Okay, this should be 3. So because if you do 1 square plus 2 square plus 3 square, so this is going to be 1 plus 4 plus 9, and that is going to give 14, right? So value of nx equal to 1, ny equal to 2 and nz equal to 3. Okay, from there we can easily find a value of nx, ny and z. So the wave function, now we can easily find the wave function. So wave function is going to be, simply it is, because 3 dimensions, it's 2 upon a to the power 3 by 2 sine nx equal to 1, right? So sine pi x upon a plus into sine ny equal to 2, right? And pi x, it is 2 pi x upon a and sine nz equal to 3 pi x upon a, right? This is the wave function. Which option is matching? Let's see. So option number D is matching, right? Option D is matching. So the wave function is this one. So very good question. Okay, I hope you understood it. So this is the answer. Next question. Question number 5. This is also a good question. Let psi NLM let psi NLM let psi NLM denote the psi NLM denote the eigenfunctions of eigenfunctions of a Hamiltonian Hamiltonian for spherically symmetric for spherically symmetric potential VR. Okay, psi NLM denote the eigenfunctions. So psi NLM is the eigenfunction of a Hamiltonian, okay, whose potential is spherically symmetric. Okay, the wave function, the wave the wave function psi equal to 1 upon 4 1 up 1 upon 4 psi 210 plus root 5 psi 1 minus 1 plus root 10 psi 211 is an eigenfunctions only of is an eigenfunction only of options are H, L square and Lz, Hamiltonian, L square and Lz. Option B, H and Lz, H and Lz. Option C, H and L square, H and L square, and option D, L square and Lz. Okay. So the question is, let psi NLM denote the eigenfunction of a Hamiltonian. Okay, psi NLM is eigenfunction of Hamiltonian for spherically symmetric potential. Okay, VR. Okay, and the wave function psi is given, that is psi 21 this 1 upon 4 into psi 210 plus root 5 psi 21 minus 1 plus root 10 psi 211 is an eigenfunction of H, L square and Lz. So which option is the correct, right? So we'll check one by one. First we'll write the wave function which is given, psi equal to 1 by 4 psi 21 psi 210 plus root 5 psi 2 1 minus 1 plus root 10 psi 1 211. Okay, so this is the wave function which is given, right? We'll check by so so what we have to check is the eigenfunction is the wave function is eigenfunction of this. Okay, for being eigenfunction, right, suppose H psi, that should be, we know that is En psi, right? If that case gets satisfied, then this is the eigenfunction, that the wave function is eigenfunction of H. Okay, so for that what we are going to do, S psi equal to En. So we'll write here, so here we'll write En, value of psi is En by 4, this is psi 210 plus root, so we will write, right, H this we know it should be like this, then psi is eigenfunction of H. Okay, so this is going to be 1/4 H root 5 psi 2 1 minus 1 plus root 10 psi, difficulty in writing, so this is psi 2 1 1. Okay, so this is going to be H psi equal to, we'll operate H with this, so it is going to be 1/4, so it is going to be En, after En psi 210 plus root 5 En psi 21 minus 1 plus En root 10 psi 211. Okay, and we can see that because here n depends only E depends only n, right, the principal quantum number, so it is going to be psi equal to En by 4 psi 210 plus root 5 psi 21 minus 1 plus root 10 psi 211. Okay, so this is going to be like En psi, this value is psi, right? So H psi equal to En psi, and so E is depending only on n, right? So S psi equal to E psi, it means psi is eigenfunction of H. Okay, psi is eigenfunction of H. Okay, now we'll check for this one L square. Okay, square psi, we'll check, and here we know L square equal to L into N, and value of this is 1/4 into psi 210 plus 21 minus 1 plus root 10 psi 211. Okay, this is the one. So we'll operate this with L square, so it is going to be 1/4 L square psi 210 plus root 5 L square psi 21 minus 1 plus root 10 L square psi 211. Okay, so it is going to be 1/2. So this we will put the value, this is L into L plus 1 into H cut square, so L is 1 here, so 1 into 1 plus 1 H cut square psi 210 plus, okay, so this is also L value is 1, so root 5 into 1 into 1 plus 1 H cut square psi 21 minus 1. Okay, plus root 10, this is also 1, the L value of L is 1 into 1 plus 1 H cut square psi 211. Okay, so here this is 1 into 1, 2 H cut square, so 2 H cut square will take common, and this is going to be 1/4 1/4 This is 2h cut square common, so it is going to be 1 upon 210 plus root 5 psi 21 minus 1 plus root 10 psi 211. Okay, so this is going to be 2h cut square psi L square psi equal to, yes, we can write in this so L square psi value is this is constant, right? So we can write this in form. It means psi is eigenfunction 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 of L square. Okay, now we'll check it for H. This is LZ. Okay, so LZ. So LZ psi will find out equal to LZ into 1 by 4 psi 210 plus root 5 psi 21 minus 1 21 minus 1 plus root 10 psi 111 211 211. Okay, this is, so we know here value of LZ equal to M H cut, right? ML H cut, the M H cut. So we'll write LZ psi equal to, so we'll operate it, so it is going to be 1 by 4. L is 0 here, so this value is going to be 0 plus this is going to be root 5 and we'll operate with this. So value of L is M is minus 1, so minus 1 H cut plus sorry okay, plus psi 21 minus 1 plus root 10. We'll operate this M equal to 1, so it is going to be 1 into H cut psi 211. Okay, so obviously this part is 0, so this is not going to be equal to some constant into psi, right? So that implies LZ psi is not eigenfunction of LZ. Psi is not eigenfunction of LZ. Okay, so psi is the eigenfunction of L square and H, right? So which option is correct? Option number C is the correct one. Okay guys, so guys, these are the question. Okay, so guys, thank you so much for watching my video, and guys, also I would request you who haven't subscribed my channel, please subscribe my channel and watch my classes which are free of charge, and my class is going to help all the students who are preparing for physics related competition examination, especially for CSIR-NET, GATE, NT exam, PhD exam, Jest, Tifr, IIT-Jam, and other exams related to physics. Okay guys, so thank you so much. Bye now.